Okay, good afternoon, ladies and gentlemen. Welcome to our next lecture, Planning and Evaluation of Development Projects. You see, hopefully, the first slide. Today is 18 November. I have to say that because maybe with this COVID situation, then people cannot get out, so they forget also what day it is. Yeah, today's Wednesday. Okay. Yeah, Wednesday is our lecture day, of course, as you know, or as many may not know, because currently I can see only 8 viewers out of what, 69, something like that. Okay. Anyway, hopefully you will, or those who don't join, they will watch the video later on. So what did we do last week? Okay, we talked about the group allocation for the exercises for the case studies, and I'm gonna repeat that today again. And I will say a few things on how we do it and what the latest updates are. Then what we do today is we talk. Then of course what we did last week. Yeah, this was what we did last week. We did discounting. Now you really know what is the formula for discounting. This is the only formula you need to remember. We talked about the investment criteria, and we had an example, and I'm gonna pick up this example again and repeat this investment criteria because that's one of the very fundamental things, and unless you have this internalized, then it will be difficult to do with the case study. But of course, this is all very simple, as you have noticed. This can be captured even though your background in economics is not so strong, as I am aware. Some of you may not have that. So, okay, this is the assignments, like the groups and the short meeting of the group with the individual tutor. So I'm going to say that. And then, of course, I will have, before we meet, I will have a kind of a presentation of how we would expect this to be. So we'll do that also. So, yes. The case study groups, they have been allocated. You find them on StudIP. We have 10 groups. Yes, the exercises have not been assigned yet because we're still checking the numbers. We don't want to give you something that cannot be solved or where really a lot of things is missing. Even though not all the information will be there, so you have to make your own assumptions. But that would happen within the next day. So actually, I promised it on the 17th, which was yesterday, and we are just checking again the calculations because, of course, we want to know what the result is. Our tutor, or in other words, your tutor would know. Okay, then we would have this. As of now, we would still say we can have a presence meeting in the big lecture hall of the university in the Audimax. But again, let's wait and see how things develop. But so far, we go for that. In any case, whatever happens, you would, in your group, work together, work with your tutor, and come up with this solution or this exercise. So these are the groups, okay. So there is, you have this again on the slides, and you have this again on the StudIP, and you would see who the date. We still leave it open to be confirmed. And you have a group name, so your group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah. And then you have your tutor, and you can contact your tutor with email, also with telephone, and you have your topic. So this is what you then will get. You get the material for this topic. And this is the second one. So each group, and by now you should know to which group you belong. Can I just ask 1 or 2 people who are listening? Can you simply confirm to me? Did you say yes? First, say I have. I know which group I belong to. Maybe somebody can say something. And the second question I have is that somebody say yes. I have. Yes or no. The answer can be yes or no. I have been able to contact my group members. So maybe somebody can say So Sunita says, yes, I know my group. Okay, so you have contacted your group, Sunita, you have contacted your group, so they all know and they all agree. That's important for us. Yeah, I know my group and have contacted most of them. Okay, great. Okay, thank you. Yeah, that's okay. So yes, you contact your group member. Yes, I said by next week, 17 November, that was yesterday, you will find your case study on StudIP. No, sorry, it hasn't happened yet, but it will happen either today or tomorrow. So you would have it then. And then you still have, of course, some time. And you familiarize yourself with the case study, and then you organize a Skype meeting with your tutor, and then you work, and then let's wait as we go. Before Christmas, we will have more information about what the situation is, and I will make further announcements. Okay, there were some who say I have not been able to contact my group. Okay, yes, we would then perhaps put some more notice on the StudIP so that people are reminded to do that. Okay. All right, so there's still time, we're still early in time, but anyway, you could try to send an email to all those other guys and see what you get. And we will see at least by 3 December, we would see where we are, and if we get, and then decide. Again, I say, and it's for those who may not be present, but who may watch the video, those who do not join a group, who do not participate in the group work, they can also not earn the 20% bonus for the group work. Those who join and complete it, and it's not graded, just do it as for minimum for the standard that we require, but it's not graded. Those get the 20% of the points in the exam. So you start with a good bonus into the exam. That's the incentive and that's the advantage. And those who don't do that, okay, they still can do the exam, but they start with 0%. And I think that's fair. That's a fair offer that I make for those of the contents that we had in the course. So, okay, what are the topics for today? So we continue and complete basically the investment criteria, and we have the examples, and then we talk about comparing projects. That's an important topic because money generally for projects is scarce, and so choices have to be made. And we look at the possibility to make choices based on economic criteria. Certainly, it's not always possible, or it's not always happening that these choices are made based on economic criteria, but at least we should understand the tools to do that. So certainly politicians can simply decide we want to do this project and just because they think it's good, and without knowing what is the criteria. This happens once in a while that let's say the German Minister for Economic Development, he visits Bangladesh, and then somebody says we should do this project, and then he says, yeah, I think it's a good idea, and then they have to do it, and maybe sometimes it's not going to be really justifiable from an economic perspective. These examples exist, but that cannot be our concern in this group. Okay, Festus, I will get back to you later. You said the grouping is not on StudIP. Okay, so that is something we have to update. Okay, Aliram, if you are here, then maybe follow up on that, or Mark. So we'll follow up on that. If the grouping is not yet on StudIP, then it should be. The exercises may not be there, but the grouping should be there, because that we already have decided. Perhaps to check again. I'm wondering why it is not on StudIP. It should be on StudIP now. Anyway, if not, then we will put it there. Okay, let's go on. So we had this investment criteria. I'm already on slide 9, and I take a sip of coffee. Okay, yeah, Alira says he will upload it. Yeah. All right. But it's good we get that feedback. Yeah, that's great that you say. Okay, where can I find the group division? Okay, all on SUDAP, it will be there. Yeah, it will be there. Okay. So now let's look at the investment criteria. This is the 4 that you need to remember. The net present value, the internal rate of return. So net present value, simply say NPV, and then internal rate of return, IRR, and then benefit cost ratio, BCR. So later this will become like, very common words to you. And then we still have a 4th one, and that's a net benefit investment ratio. We'll talk about that later. And then there's a 5th one, which actually is not really, in that sense, an investment criteria. It's the payoff period, because it doesn't really give an information about the efficiency of the investment. It's something else, but we nevertheless add it as an additional criteria to judge the feasibility, the economic feasibility, and let's say, the attractiveness of a project, whether it should be implemented or not. So these 4, this is the one that you really need to have internalized, at least for the exam. So I go on slide 11. This is my example, and it says here net present value solution. And you see here these horrible formulas on top. So the NPV formula, again, this is simply saying there's a stream of benefits from 0. And remember, I repeat again, we use this concept of a year 0, which is the year of the investment, up to some period n. And so you have the stream of investments, the stream of benefits, which is BT. And since they occur in different times periods, they would have to be discounted to a certain base year. Yeah, and the base year is 0. And then we simply deduct from that, do the same thing for the costs, and then we sum it up, and that's the sort of the benefit, the net present value, Okay, and if we turn this around, we express it as a fraction, we got the BCR, the benefit cost ratio. So that's all pretty simple, and I think you can make sense out of that. Now, just look at this very simple and, of course, hypothetical example. So your project will not look as simple as that, and it wouldn't have also those simple numbers. So this is just for pedagogic reason that we do this. So okay, we have a project here, and that has an investment. Remember, we always said the project starts with an investment, and the investment is 100,000. And this is in year 0. So you see there is something in year 0. And then you will see something else that is interesting. If you go down in the column, you will see here the discounted costs is also 10,000, which simply says we do not discount this amount. And we don't do that because it's the base year, right? I think that's pretty clear. Then we look at the data. So we have a 5-year period, a project of 5 years. And every year the cost is the same. So remember, if the cost is the same or the amount is the same, it's an annuity, then what can we do in order to kind of make this into a net present value? So I'm gonna ask this question and maybe somebody can answer it, what we're gonna do. Anyway, you don't really realize what's happening because you're using the Excel. But the Excel is doing something, and I could ask you, what is the Excel doing with these numbers? What would it do? Okay, so this is the costs, and this is the benefits. Now, also we said, sometimes there are other terms are being used for the costs. You would call outgoing payments, and for the benefits, you would call it incoming payments. So this is sometimes what you also find in the literature or in project reports. So don't get confused about that. But okay, to use costs and benefits also consistent because we call it the benefit cost ratio. So why not call it costs and benefits? Now, okay, here, then we go down and we go in this row. the discounted benefits. The discounted benefits would be then, remember here is an information about the discount rate is 0.10 or 10%. And that means if we take the benefits, I didn't talk about the benefits. Okay, so what you can see with the benefits is that in year one, it starts a bit small and then it increases to 50 and then it drops again in year 5. So that's just the pattern of the investment. It depends really on the nature of the investment, what kind of benefit stream you get. For example, if you have a reforested area, so if forest is reforested or a forest area, then of course you would not have any benefits during the first maybe 5, 6, 7 years until the tree has reached some stage where it could in principle be harvested. Of course it may not be harvested, but it starts to have a value, and below that the value would be maybe even 0 or very low. So it may not always be a pattern like that. This is whatever the project is, this is the pattern. 25 and it jumps to 50 and it jumps down again to 25, just for pedagogic purposes. So therefore, we would discount that value because, and even the first year we would discount because there's another convention in this analysis, which I should tell you. And the convention is that if that amount occurs, it's always at the end of that year. That means, okay, this 25 is counted as if it occurs at the end of year 1. So it will be discounted. And if it's discounted to the beginning, or which is the end of year 0, so to speak, then it's, and you can try it out, you simply calculate. Yeah, what do you calculate? Someone can say, what do you calculate? How do I get from the 25 to the 22,279? What is exactly the number that you have to write down? I'm asking you because you can figure it out. Okay, and then it goes on to second year, and you can see immediately how much that really, affects. So in the year 5, out of this 25,000 becomes 15,523, just at a discount rate of 10%. And the same thing happens to the discounted costs. Now notice again, the 10,000 will not change, and then all these other costs will change according to the discounted rate. Then on next door you have what we call the cumulative discounted benefits. So in the cumulative discounted benefits, we add them up year by year. So we add year 0, which is 0, of course, there's no benefits, to year 1, which is this amount, and then we add this amount again, and then we get 64. So it's cumulative, yeah? So we end up with a cumulative benefit of 151,289 in year 5. Okay, and the same thing we do with this cumulative discounted costs. And that would, here you see that the 10,000 occur because these are costs. And then you add them up. Yeah, so here we had 9,000, so this becomes 109,000, 170, 124, 131, 137. This is the cumulative discounted costs as we go year by year. And then we can simply simply make a balance, and the balance is clearly negative in the first year, and it is still negative in the second year, and it is still negative in the second year, yeah, and still negative in the third year, and only in the fourth year it becomes positive, and in the fifth year it becomes more positive. So this also can tell us, this balance row can tell us something, and I can ask you which of the criteria that we did not discuss yet, but you can pretty easily guess, would be derived by looking at these numbers, yeah, by looking at this balance, and the balance which is from 3 to 4. So what does that mean? What does that mean? I'll leave that as a question. So nevertheless, what we can say is we calculate the NPV. So how did we calculate that? Can somebody write in the chat? How do we calculate the NPV? I'm waiting. I'm going to open the window until you have given me an answer. So you might hear some birds from the garden. Actually, I still have a lot of birds because I still have apple hanging on my tree, and all the birds come and eat them. Okay, never mind. Maybe you don't like to do that. So the NPV, of course, is the difference between the cumulative discounted benefits, 151,289, minus the 137,908. That's exactly this formula. That's exactly what this formula does. And you get it here also. Yeah, if you take the cumulative, the balance here, then you get the same amount. So you could also say that. So it's the same amount. Now the benefit cost ratio, how would you get that? What would you do to get this 1097? So basically 1.1, you could say. Okay, the grouping has now been posted. That's what Alira says, so kindly check to be sure you're included. You may also contact your group members to arrange the plan now. Okay, so thank you, Alira. Now it's there. And everybody, those who listen now and those who look at the video later, should be able to access that, okay? So you know to which group you belong, and then later you will be informed, or you will receive the particular, or you pick, that's the way we would do it, you pick the case study that belongs to your group. Okay, so I come back to benefit cost ratio. Yeah, that would simply be if I divide the 151,289 divided by the 139,908, then I will get 1.098. What do you think about this benefit cost ratio? What would it have? Yeah, okay, somebody said, Andrea said, divide the cumulative discount with the cumulative. Yes, okay, correct, yeah. Okay, so yeah, of course, that's simple, but it's still necessary that you internalize this, because you will have a much more complex spreadsheet than what I show you here. So, okay, we have three things that we know. We know the NPV, we know the BCR, we would know the payoff period. We skip for a moment the net benefit cost ratio. That we will do at some later point. But then on the next slide, on slide number 12, you could see something very interesting, because you would see the NPV in relation to the discount rate. In other words, if the discount rate is going up, then the NPV is going down. Okay, yeah, no, not 97 cents. So somebody says here, the benefit cost ratio of 1.097 means that for every dollar spent, 97 cents is gotten as benefit or profit. Okay, I would leave that to your discussion. That maybe somebody can say, yes, he thinks that's correct, or somebody could say, maybe I think that's not correct. Maybe it's a misinterpretation. So perhaps someone else can comment on that. I would leave it open for the moment, and then, of course, we come back to it again later. So I go back to my graph on graph 12. So I put below here, the R is 0.10, the NPV is 13,381, the IRR is 15%, 0.55, and okay, yeah, sorry, I jumped too fast. Why do I say that? Why is the IRR 15%? This is the additional information I got from this graph, and I didn't use a formula for that. What do I do to get the NPV? What physically do I do if I want to get the IRR? And that's, I should say this clearly, this is the most frequent, most common criteria that is being used in cost-benefit analysis. It's mostly the IRR that is presented by the World Bank and so on. Why? They are banks, right? So they like interest. If they are banks, they want to put it in this way. They can't handle NPV so well. So for the banks, generally, it's the IRR. That's what they are talking about. And it looks also like the IRR is easy to compare, because it's a percentage. While the NPV, okay, the NPV for a small project it's probably also small, but it could still have a very high IRR, right? So think about that, and we will have some more details or some more some more examples on that. So okay, now to the question, where do I identify the IRR? It's according to the definition, the IRR. The IRR is the discount rate at which the NPV becomes zero. So you increase the discount rate from this direction, here from 0.1, from 1% to 10%, up to 15%. And as we can see, when we reach 15%, then the IRR is reached. Yeah? So the IRR is reached at about 15%, actually 14.9 or something. So what's the interpretation of this? Now we know for this project, this simple example, our IRR is 15%. What does it mean? How would you translate this information into something that is really understandable? Okay, I leave that question open because that's one thing when you always later on you need to present that, and then you need to say something about that. Okay, I'm gonna close the window, it's too cold. So, okay, I didn't get an answer yet, so never mind. We move on and we come back to this question. Anyway, we come back to it several times. So, scenarios for using investment criteria. Okay, decide on independent projects, whether to implement or not. The simple question is, are they economically attractive? In other words, there's enough budget by the Ministry of Economic Cooperation and Development, or by the World Bank and so on. So it's just simply a question, is this project economical or not? It would not compete with the other projects. If that's the situation, yes, then it's pretty simple, right? Pretty simple what we could do. We all simply have to calculate the NPV, IRR, what have you, for this project. And then we can decide for clear cut for NPV, if it's greater than zero, it's fine. For IR, what would be our reference point? Of course, it's greater than zero also. So, but greater than just an IRR of 1% maybe is not enough. An IRR of 5% maybe also you don't feel comfortable. And again, I can ask you why, because anyway it's positive. So if the NPV is 5%, but as I indicated, this is not the reference system for the IRR. What is the reference system for the IRR? That's the first part. Yeah, if it's in the first part, it sounds very simple, but there's still, of course, a little bit, a little bit, or there are some variations that have to be considered. Then on the second point, we have to decide which of the mutually exclusive project to implement. So here it's more like, you have to decide, you want this project or this one. So which one you do? Okay, it can be a project more on environment, it can be more a project on infrastructure. This, of course, has other criteria, but at least you would say, if you apply cost-benefit analysis correctly, then it would bring, it would choose this result, or this project where this project brings more benefits to the society. So then it's mutually exclusive, and we need to have a way to compare them. And that is not always easy, as I will show you on some of the next slides. Then you rank projects until your budget constraint is reached. Right? Sort of, okay, the ministry in Germany has allocated I don't know, some 40 billion, and then that's being used for projects. And then you would kind of rank your projects until you have the budget constraint. So this is this comparison of project, what I was talking about. Look at this. Look at the two graphs. So you have here the benefit cost ratio on the first panel, and on the second panel you have the NPV. Let's talk about the benefit cost ratio. So we said the cutoff point is 1. If the project exceeds a benefit cost ratio of 1, then it would be acceptable. However, it all depends, and that's what I said several times, it all depends on the discount rate. Yeah. So here again is the relationship between here in this case, the benefit cost ratio and the discount rate. And obviously project B will reach that point where this discount rate becomes 0, will reach that point. No, not the discount rate become the NPV. The NPV becomes 0. So the NPV, sorry, what's wrong? What I was saying. So 1 is the cutoff point, and at that point the BCR becomes 1. And if I increase the discount rate, then there will be a point where project B will have a benefit cost ratio below 1. And you could see for project A, it's a different project, this will be much later. Yeah, the point if we increase the discount rate, where then the discount rate would be below 1, would come at a much higher discount rate. So obviously these two projects are very, very different. And if I do that on the NPV side, and this is purely hypothetical, so this is not identical with this one, yeah? It's a different one. It's purely hypothetical, but it's just curvilinear and wouldn't really matter. Here we have the NPV, and we have the same story again. Project A has a high NPV, but it goes down very quickly, and NPV and the NPV for the project B is lower. And as said already, this can very much happen because it depends if you have a really $1 million project or you have just a small project with a few 10,000s of euro. Then of course the small project cannot produce as much NPV as the big project, but that's not the main point. So what you see here on this graph in the panel B, or on the right side, that this project B is sensitive to the discount rate, and here the discount rate would be 0, and here at this red point intersection would also be 0. And what, again, my question to you, what does this mean? What does it mean if the discount rate, what does it mean for the NPV? So the NPV becomes 0 at that particular discount rate. So it's called what? What is that point called? Where the NPV curve cuts the discount rate, yeah, where cuts or reaches a level of 0 for the discount rate. Okay, that's the, you could say, well, never mind, let's ignore that. But I want to ask, now it's another graph, and then come back to that. So here is a bit different. They overlap, right? So they overlap when you say we use a very low discount rate, then project A will be better. If we lose, if we choose a low discount rate, project B will be clearly dominated, but there will be a discount rate at some point higher when this project B is exceeding project A. Okay, so it's IRR. Yes, okay, that's correct. It's IRR. That's the answer here, putting on. Okay, and then so here we would have some interesting case where they would somehow cross. So there would be a discount rate where they would actually be equal, right? In this point, they would actually be equal. So, and why is that? How come the reaction is so different to the project A and project B? Can somebody imagine what are these? Just in principle, what kind of projects are these? So you would see the project B, it would become less sensitive to the discount rate, because at yeah, when you see that when you change the discount rate, which project is reacting more. So when you lower it, project A obviously gets a lot better. So while sort of at very low discount rate here, even discount rate 0, here project B would already be 0, but project A would not be 0, so it could go on. So think about this. This is why I'm saying this, because later you generate these graphs yourself, and this graph tells a story. So it tells you something what's going on with this project. And I leave it for the moment, because there will be still plenty of opportunities to revisit that issue. Okay, now we have the question, which of the two projects is better? Now, what do you see here? This is again very simple, and I'm on page 17. Which of the two projects is better? So here you have project A, and it only runs, for simplification, it only runs 13%. It only runs 2 years, and it has an investment of 1,000. And after the year 2, it has a return, and then that's all. We don't know anything between. And project B1, that also has the investment of 1,000, and the return, which is bigger, only occurs at year 5. Yeah? So of course it's hypothetical, but it can be imagined. And now if we calculate the IRR for these two projects, and that is completely, of course, that's this project in a way are similar by the amount that is invested, but they are dissimilar in the period that they run, and that is the problem, right? So if we can ask the question, can we simply compare these numbers? Can we simply say, okay, project A has an IRR of 14%, while project B has an IRR of 9.9%, and the NPV is 157 and 195. So project B actually, and this is the discount rate, 6% or 0.06, is more economical when the discount rate is low. Yeah, this is what the NPV would react to. And the IRR, which doesn't need a discount rate, that shows clearly that stronger project is project A. And now, how do we resolve that problem? The problem is that they do not occur at the same time. So for project B, you have to wait until the 5th year before you can earn something, and in project A, it's much faster. It's already there in year 2. So now how do we solve that problem? And we solve that problem by doing a very simple trick. So we say, all right, project A is completing in year 2, and while project 2 or project B is continuing, and it does nothing, it has no returns until the last year. Everything is put in the last year. So now we could say, okay, in order to make these two projects comparable, they should be equal in 2 criteria. One is the initial amount, that is assured that this is the initial amount, but the second one is in the labor, it's in the, what did I say? It's in the amount that is reinvested, not in the labor. That is wrong. In the amount that is reinvested. So this amount that I earn in year 2 can be reinvested, and now I compound it. Remember, now you need the compound rate. I compound it to year 5 because this is the end of project B. So then I would get, so if I would reinvest that, I would get 1,548. Now they are equal. If I convert it like this, then the two projects are equal. They have the same time horizon, and they have the same initial investment. So now I can really compare them on the basis of IRR. And what do I see? I see that project B is the better one. And then it's consistent, right? So the 195 that stays, and the discount rate is up to 9%, 9.9%, while it would have been 9.1% only in if we do the or if it's 9.9. Yeah, the combined project of A and B, which comes out of A and the supplement, that will be 9.1%, and project B will be 9.9%. So there was somebody who said this is fixed cost. No, it's not what we would call fixed cost. We would simply call this the reinvestment. Yeah, the reinvestment. So it has nothing to do with fixed cost in this case. We may occasionally come to that question. What do fixed costs play a role? But in project analysis, the fixed costs do not play a role, because remember, and I would have to go back to my earlier table, and in this table you could see that well, what did I want to say? In this table, I don't want to go back to the table now. But in the table, you saw that we had the initial investment in the year 0. So we don't do any fixed cost. The fixed cost would be if we calculated the depreciation, which we don't do. I think I know what is meant when you say fixed cost, but it has nothing to do with the fixed cost. We don't call it fixed cost, we call it the initial investment. And of course, that you could say, yeah, that is already fixed, yeah, but it's not the fixed cost per se. So let me make that clear. Okay, now here we have an example from the literature. I take some coffee. And you see what's going on here. So we have small-scale irrigation and we have large-scale irrigation. So naturally, the NPV, and this is a millions unit of some domestic currency, you see that the NPV of the small scale is lower than the NPV of the large scale. But you see that the IRR of the small scale is higher than the IRR of the large scale. So small scale exceed large scale. So what? Small is beautiful, or what is the reason? And this one is, the last column is the costs, millions of unit domestic currency. So this is the investment cost that shows you the dimension. So the dimension of the large scale is 5 times bigger than the small scale. But the small scale pays off. Well, both perhaps we may pay off, because in both cases the NPV is positive. Yeah, against what I said, then maybe the 16 is already near the borderline. So anyway, the question would be, how would you decide in this case? What information would you need to decide about this case? Obviously, we get sort of conflicting results. Yeah? The IRR is better, so the IRR would be then relevant if capital to some extent is scarce, and this may be the case in that developing country, although the IRR as a tool does not itself assume that this would be scarce. But this is the real world situation, much more so. And so which one would we decide? Now, you can maybe write something in the chat what you would decide in this case. Because if you present a table like this, suppose your group presents a table like this, then we are not so sure. What should we do? You would have to come up with a recommendation and give a reason for that recommendation. All right, what are the advantages and disadvantages? So in comparing projects, different investment appraisal decisions may result in different decisions, and it depends on the objective of the comparison, which criterion is most appropriate. And what we can say is that the internal rate of return is useful because it's clear and easy to understand the relative number. I think, and most people might think that's why it's being used so often. The IRR is, of course, misleading for mutually exclusive projects of direct lending. It's misleading for mutually exclusive projects for different lengths, not lending, for different lengths. And that includes the interest on the supplements to compute the correct IRR, right? So the correct IRR would be the adjusted in order to make the projects have, and we call this when it comes to the equal amount of investment. Of course, it's not exactly equal what we mean, but more or less equal, and that we call the width of the project, and then the duration of the project, we call it the depth. Yeah. So if both are incompatible, if both are more or less on the same scale, then that is the time we would say, okay, now we can compare them. Then a comparison is possible. But if they depart a lot, like this small scale and large scale, then really it doesn't really make sense to do this comparison, unless you would say, okay, what is coming out of this project, it can be scaled up to something else. Then you could do that. Other advantage, disadvantage, the NPV depends on the volume of investment per project, or the volume of project. If the project with higher net benefits should be identified, the NPV is more useful, obviously. Yeah? The NPV assumes that unlimited financial resources can be borrowed from, and now comes the sort of that it can be invested in the capital market. This is what we did in this example with the supplements. We invested it. We assumed that we invested in the capital market, because what else should we do? We could not say we create another project that is identical. Then we could have merged these two projects, but we wanted to say, okay, that money from the first case will be reinvested at the capital market, and that's why we can use the 6% in that case. Now not anymore, but we could use another one. Okay, so this is what we had. This was on, now it's on slide 22, and here we talk about choosing the discount rate in financial and economic analysis. So 4 questions that we have. Which costs and benefits are to be included? How are they to be valued? We all haven't really discussed that. And then the question today is what discount rate to use. So maybe it's an important question, and you will see also. So the difference, what we have to do here is make a difference between financial and economic analysis. And that's something we would put quite some emphasis now on when we do exercises, that we always have to differentiate between the financial and the economic analysis. And the financial analysis, in a nutshell, it means to accept market prices as they are. And then, if we accept the market prices for agricultural products, for intermediate goods, for internationally traded goods, and then we consider also the inflation in here. And then what we have, and this is what the kind of the conclusion is, we would choose a private discount rate, a market interest rate. That should be the private discount rate. Now, in the economic analysis, which is what we finally do, we judge the project from an overall economic perspective, that means for the society, we would use adjusted prices, and these are shadow prices. Somebody knows what is a shadow price? Can you give an example for a shadow price? What is the shadow price? Okay, we'll see. Somebody may come up. Um, so, and then we have, and we'll go to this in detail, so don't worry, yeah, where we say we have other market processes and we use the shadow exchange rate if there is, for example, a lot of domestic production and very little in export. And then we would use the shadow exchange rate, or what we could do, and this is another tool, to adjust the prices. And it's the standard conversion factor. And adjusting the prices always means to sort of convert them to world market level, yes. And then we have something like a social discount rate, the interest plus time preference. So the interest is somehow the result of some market process, and the time preference, of course, in a way also. But we would have to consider in the social discount rate, let's say, the patience of the society. I think I told you last week this example about the Bangkok girl running over the street. So she was totally impatient, but a discount rate would rather exercise that, or would capture at least that level of preference, time preference. So it's like if you ask someone, what do you prefer? So it comes down to discounting again. If you ask someone what he prefers, something smaller now versus something very big in the future. Yeah, that is the classic question for discounting. Okay, so private discount rate and social discount rate. And now we talk about the financial analysis. This is on slide 25. So the financial analysis would have different possibilities. To do this, we can use the marginal cost of money, the rate at which money can be borrowed. It can be the opportunity cost, the rate at which money can be invested. And it can be the decision that is made by the, it depends on the invested capital. So this is the different possibilities for financial analysis. Okay, next slide. So the economic analysis, what we would have for the discount rate is the social opportunity cost of capital. And what does that mean? It reflects the amount of money that society is willing to save. And it's mostly used by the developing countries, and they would say the discount rate would be between 8 and 15%, maybe not now anymore. And then the social rate of time preference, which value does the society as a whole give to future consumption? And it assumes that society has a longer time horizon than individuals, and therefore interest rates will be lower, right? Sort of this is the crux, that you have a relatively low reference point so that your project is well above, and then your project is also economically. Mostly what is used by independent countries is 3 to 7%. And then we can weigh both of them. So we have the social opportunity cost and we have the social rate of time preference. And yeah, that is sometimes, it comes out sometimes a little bit arbitrary, and actually also the development bank. So this is a paper from Mr. Swang. He used to be the chief economist at the Asian Development Bank, and he put up this claim that they should be in the order of 10 to 12%. Can also include the rate on which the capital might be borrowed for the project. That could also be, as a basis for the social rate of discount. Okay, so this is some literatures which I guess you already have received. I hope so, at least. And then you can reassess this. Now, let's go to another point. And that's equally important, and especially important for the agricultural projects. And those who are in agriculture or in related fields, they would immediately know what is adoption. But even if you are in industry, you would also know what is adoption. And and why adoption is important. Now, you can already answer that question, why is adoption important, considering that there is such thing as discount rate. And obviously very clearly, because if adoption is late on some whatever it is technology that yeah, is complicated, and then it will delay. And even though if the technology is very good, the benefit per unit is very good, but the adoption is low, then it will mean only a few households are added to the rate of spread of the technology. And that will make then, if most of the adoption takes place later, then the discounting will make it very small. Yeah, that's why there is this connection. So let's look at that. Okay, what's the adoption process? So that just to be aware how that would be captured into a cost-benefit analysis. So adoption describes the stage in which an individual decides to make full and regular use of an innovation, for example, a new strain of a more efficient rice or something. So adoption of any technology. And there the question is when will it be adopted? And only if it's adopted, of course, it can influence our cost-benefit analysis. The technologies that are not adopted by the final producer, which in our case mostly would be the farmer, you don't need to the adoption process describes the process an individual goes to before adoption. So here we have the steps. So we say, okay, there is awareness first, and then there is some interest in that technology. Then there is an evaluation. This is what every one of you does when you are faced with a new smartphone. Then maybe you try it out, and then you adopt it, right? So it's a kind of a process. And in a project, you may try to influence this project, and it could be part of a project cost. So there are different types of innovators and adopters that make up this adoption curve. So there are some guys who are really jump quickly on something new. That would be the innovators. And then they are attracted to change. They are risk takers. And then there are the early adopters. This is the opinion leaders. They adopt new idea early, but maybe they're also cautious. So if we have the early adopters, depending on the technology, that there will be early adopters. Then we call in the third phase, we would have the early maturity, and then it would have the laggards, those who start something, start much later, who are suspicious at the beginning and they will adopt new ideas only when they become a tradition. And of course, the more you shift this curve, the less innovators, the less early adopters you have, the lower will be your benefits, and the more the discount rate which will factor in. Yeah. So this is a hypothetical graph, how it would look like in different stages. So the research and development stage, then there is, ideally, this is how it would be, but it's not always like that. Then you have the introduction phase, and you have the growth phase, you have the maturity phase, and you have the decrease phase. So clearly you can see, depending if this curve is steeper, this would directly affect the benefit. If this is like this, yeah, and then goes up, so then you would have, if I would just turn that graph a bit, if it would go up like this and then goes up, so I would have to wait for a long time before my vegetables or before something could be adapted, some new technology, some new crop. So, and below here you have the stages again. So you will see when you do the spreadsheet how this is playing into your results. And there are a number of factors that influence that. And again, that is why you can always think when you assess your project, should there be something else that is factored into the project in order to influence the adoption rate? Because there could be constraints to adoption, and if you kind of remove those concepts like access to information, access to credit, infrastructure, cultural factors, and prices. This would all be factors that influence it, and yet you may check in relation to your cost-benefit analysis what role do they play. Okay, so this is an example, and this example, maybe we even have it as a case study. I'm not quite sure, but we used to do that. And that is the zero tillage technology in India. I don't know if you are aware or are familiar with this term zero tillage. Zero tillage means you don't plow the land, and there is this the conservationists, agriculturists, they say you shouldn't plow the land because if you keep the land, you after harvest you don't plow it and then you leave it. No, you just kind of seed the seeds into the harvested field, and so that's what called zero tillage. And this was a study that we did in our impact evaluation group, and we did that, and we simply said, so suppose this process was earlier or this process was later, and it depended. The adoption of that technology depended on a machine, and it's kind of when you go plowing. Okay, you have a plow, but here you would seed directly the seeds into the unprepared, so to speak, the unprepared soil, and then it will become key whether this adoption will follow which path. You could see, you could see this path here, how the zero tillage has been spreading, and if you would, how it would be spreading if no much extension effort were undertaken, and how much is spreading because some extension input is being done. So that's what you could factor into your cost-benefit analysis. So here we say there is an influence on slide 34. There's an influence on project success. The agricultural development projects often aim at the transfer of new technology, and therefore the adoption rate is crucial for project success. The adoption often follows in stages, and some of the factors that influence adoption can be included in the project activities, like access to information or access to credit, access to or availability of infrastructure. So this would be classic factors. Other factors could be cultural factors and price. They are more demanding to measure. And then in cost-benefit analysis, one has to be careful in scaling up results found in pilots. Generally, the decline of the per unit benefits has to be taken into account. Okay, this last point, why we have to be careful when we scale up the results. And here I have maybe an interesting example from Indonesia when I was part of an evaluation mission of the World Bank judging an agriculture project in Indonesia. And so I was coming in with some colleagues at the midterm review, and the midterm review had its job to reassess the calculations of the ex-ante analysis. So in the ex-ante analysis, some economists at the World Bank he came to a conclusion that this is a very attractive project. And what he did was that he used the results of the pilot and simply scaled it up, right? So he said, there will be farmers who adapt, who adapt early, and some who do it later. So these factors can be included in the project activities, and other factors are subject to uncertainty. So the project cannot do anything. On this on this issue. So there is no way that the project can, for example, make an activity that the prices will change, because whatever the project is, even if it's a big irrigation project, it cannot influence the prices. It can also not influence the cultural factors, for example. So if the behavior of people, there is very little. Think about now what's going on with the German government or the German chancellor. She tries to tell the people every day, again and again, they should be careful, but nobody listens to her anymore. And so, if you want to do influence cultural factors, if you want to do, I can also put their behavioral factors. Well, then you have to really make a campaign. You have to do something very targeted and so on to change behavior of people. So thinking about that in terms of a project would be very hard. So some factors you can influence, and you can identify them as let's say, as project activities. Then you can cost them, and then they would affect the adoption rate. But some others you cannot. And yes, as I said, you have to be careful in scaling up results. And that's I probably didn't tell you the whole story. And that was simply when you scale up results from a pilot. The example really is from that Indonesian project is what this economist at the World Bank was doing is she took the results from the pilot, and then mainly the benefit of the project was reduction or savings of chemical pesticides, because the project was on the famous, which some of you may know, the Farmer Field School. And they had pilot areas, and there you could show, okay, so many percent the pesticides are being reduced. And then she scaled it up to the country. And then I did a simple calculation that, okay, so if you scale this up to whole of Indonesia, Indonesia is a huge country, then what's going to happen? So how much pesticide is that? And then I figured out, if you scale it up to the country, it will be more pesticides than the whole of Indonesia is consuming. So of course that it was a total overestimation of the benefit. So I think initially she had an internal rate of return of 32%. And when I did that and I kind of make it more realistic, then I got down, even in the worst case scenario, I got down to 2%. And if it were 2%, then it will be very hard for the World Bank to continue that project. And so I submitted that report together with my colleague from the FAO, and we said, look, I think you are really overestimating this project, and you must maybe change the design of it. And okay, so what do you think what happened after that? What do you think what they did when they got this result, when they got this report? Of course, they were not happy. Yeah, they were not happy. What do you think? So I ask you, what do you think they did? So I submit my report, I recalculated, I said, look, this cannot be. You're scaling up from a pilot, and then I'm checking on your major benefit, this is savings of pesticides, and I scale it up, and I look into statistics, and I say, this is the total amount of pesticides that Indonesia is using, and what your project analysis assumes that it's reducing more than 100%. So that's not possible. And I have even a project that would save all the pesticides of Indonesia is not possible, right? So she probably, that economist didn't think of that, what the consequences would be, and was not, maybe not very familiar with agricultural conditions, and didn't really look into this. I ask you, what do you think they did? What do you think? Did they send me, send me a gift and said, well, great what you did? I don't know, are you still there? Okay, nobody says something, so I tell you what they did, what they said. They said, okay, they said nothing actually, and they just changed the assumptions again. Yes, they ignored it. Yeah, okay, right. They ignored it. They said, no, okay, we don't want to change the design of the project. We already have started it that way. And yeah, we already came up with this nice internal rate of return. And so if you're telling us, maybe it's wrong what we did, but okay. Yeah, so anyway, the good thing is that cost-benefit analysis can make this clear, can show this. And I think that is the nice thing. in if we are doing analysis like that. Okay, I think today I didn't have so many slides, and I think that is fine. I would simply ask you to really review those investment criteria, the simple table that I gave you, and then try to get, now since you have the information on the Stud IP, look after your groups, try to contact them, and in the next couple of days we would give you your exercise so that you get your exercise. Okay, so I have a question. In a situation where a project was economically viable, but the adoption rate of the technology was analyzed to be slow, how do we make the right investment? Okay, yeah, interesting question. I think if the adoption rate of a project is slow, then the IRR will also be low, because it simply means it takes a long time before the benefits will occur. And if it takes a long time before the benefits will occur, the NPV will be low, because if you discount them, let's say typical case reforestation project, so you have to wait for 20 years, 30 years sometimes, mostly things related to climate change, yeah, and climate change protection projects or projects where you want to, alter the process of climate change. They would always take some time. And if you would, you have to apply discounting. And then if you then look at the NPV, given a certain discount rate, a high discount rate, then you would come to the conclusion, oh, it doesn't pay off. So generally the answer is, if your adoption rate is very bad, very low, then your project does not pay off. That's why they are related. That's why I say, okay, if there are reasons to believe, or you have that information from other sources that, wow, the adoption rate is low, then you have to either say this project is not going to fly because it's maybe too complicated, the technology too complicated, or you think of changing the design and bring in some activities that can make the adoption rate to be higher. Like, for example, you would say, okay, not only have irrigation, but also have some effective extension campaigns or extension systems, something like that, right? So you cannot see that independently. If the adoption is low, then the internal rate of return is low, and then the conclusion would be, don't do this project, yeah, unless you find a different design where you say, okay, we try to influence the potential adopters so that they will adapt faster. Okay, that is the conclusion. Okay, yes, I think I have this is all my slides that I have for today. So anyway, yes, I was probably faster than I expected, but it doesn't matter also, because I think you want to do some checking on it. Okay, I have another question. Some scholars said that no laggard in the world, simply it is a matter of awareness. Okay, if you create more awareness, then would not be. What do you suggest to her? Okay, nice, a very interesting statement. So there is no laggard in the world. It depends on what you are saying. Okay, maybe what you are talking about. Perhaps when it comes to fashion, I believe there is no laggard. They all jump on it, right? And it depends on the technology. But now think of the anti-COVID measures, right? There are laggards. There are people who simply resist to do it, to wearing a mask or something like that. So I don't know who said that, but the reality in project analysis shows that there are, and this is many of the impact studies that I have, for example, been doing together with the consultative group of International Agricultural Research, adoption rate varies a lot. So there can be, and that is often because the product that is being tried to implement, or the technology or investment, something that is imposed or that is introduced to a community, to a target community, is often too complicated. And then it is slow. So not everybody will jump on it. I think if it's yeah, I agree. And I mentioned the word fashion because this model of the adoption rates, this what I showed you, this sort of different stages, this is from Everett Rogers, right? Rogers, not Kenny Rogers. He already passed away. And Everett Rogers, he had this book, Diffusions of Innovations, and his first study was fashion, right? And actually in fashion he came up with this pattern. And so I'm not saying all the innovation processes are going that way, but I think many innovation processes would that be. So I would be, maybe the meaning is a bit different when you say there is no laggard in the world. But there are people who are kind of lagging behind the majority. And there are people who are quickly jumping onto that. Otherwise, if that were not the case, then I think if all would sort of behave more or less the same, then I think we would have less inequality in the world. There would be more equality in the world. So that would be my comment on this. But thank you very much. It's a very interesting statement. So anyone have a question still? Some other things that we discussed? You will see that adoption rate always will bother you in your case study. And you can make assumptions, you kind of, when you play with the numbers and say, okay, if we change that, what would be the effect on the IRR? That's always a very useful exercise to say, which are the key factors that drive the result? And once you have your basic spreadsheet established, then you have your tool to play with, which you will see later. I see no more questions. Then, yeah, okay. Then I think we would call it a day. I have to say that, every day I have to wake up at 5:30, and then we have online training with our research collaborators in Thailand, because Thailand is 6 hours ahead. So when we start the training, it's 7, so it's 1 o'clock their time. Yeah? So you can imagine what impact the COVID have on the life of the researchers or on the life of professors. So anyway, if no more questions, then I thank you for listening, and then we come back next week and going through more material. I think we still have quite some material to cover so that you feel in a good position to do this analysis. All right, thank you very much and goodbye.